In this video, we're going to go over problem number 3 on the secants, angles, and arcs exit card. So this problem is really difficult because you're just given a lot of information to start with. So I actually have up here that arc BC is 180 degrees already. And I just found that because I know that the diameter is BC. So this whole arc is going to be 180 degrees since it cuts the circle in half. And I'm going to come back to that information in just a moment. So here I want to solve for X and for Y. And one thing that I notice is that Y here is one of these vertical angles that are made by the two secant lines, and they intersect inside the circle. So our notes from this week tell us that Y is going to equal the sum of those two pink arcs, so X, and I'm going to call that arc DC for now, all over 2. So we're going to use this formula to solve for Y eventually, but first we need to figure out X and that DC. So DC here, back to last week, I see that this arc DC is made by this angle DEC. And that angle measurement is 41 degrees, which means arc DC has to be double 41 degrees. So this is going to be 82. So I can fill that back into my formula. So Y equals X plus 82 over 2. And we still need to solve for X. Now, solving for X is where it's going to get a little bit complicated. And this is where a lot of people got stuck. So far, I know this DC part. And I know this whole BC part, and then I'm gonna use this ED part and subtraction to figure out what X is. And I'm gonna find the measurement of ED by doing the same thing that we just did for DC. So I know that this angle is formed, and this arc is formed from this point C on the circumference of the circle. If I can figure out what that measurement is, and I'm going to call this A, I know that arc ED has to equal 2A. So given the triangle that has 78 degrees in one angle and 41 degrees in the other, I can use that to figure out A. I know that's going to have to equal 180 minus the 78, which is 102, and then minus the 41 again, which is 61 degrees. So my angle A here is 61 degrees, which means that ED is double that. So ED has a measurement of 122 degrees. So this part is 122 degrees. Okay, now I'm going to erase that to make a little bit more room here. And then we're actually going to go ahead and solve for that X piece. So I know that this whole ED is 122. And I know that this DC is 82 degrees. So if I add those together, 122 and 82, I get that the whole EC part is going to be equal to 204 degrees. Now I know that X plus BC, so if we have EB plus BC, that's the same thing as that whole EC length. And I just found out that EC was 204 degrees. EB is my X. And I know BC, because that's my diameter, is 180 degrees. Now I can solve for X by subtracting 180 from both sides. And I get that X equals 24 degrees. Now I can use that to solve for Y. So we're going to come back up here to this formula. I'm running out of room, so I'm going to go ahead and erase our work for solving for X. And we're going to plug in X to the formula and solve for Y. So we get Y equals our X value, which is 24, plus 82 over 2. So 24 plus 82, that's going to give us 106. And 106 divided by 2 is going to give us 53. So that's how we solve for both x and y in this problem. So remember, when you're solving these, we're using the relationships we learned this week about the secant lines, but we're also going to be using the central angle and inscribed angle relationships that we learned last week. If you have any questions about this material, please let me know.